Hi everyone, welcome back to our channel. Today we are going to determine the problem number 5. What the question is, determine the Z parameters of the pi type attenuator circuit. So this is a pi type attenuator circuit. We want to find out the Z parameters. So what are the Z parameters we have is, we need to find out Z11, we have to find out Z12, and we need to find out Z21, as well as we have to find out Z22. Let's try to simplify the problem. Okay, already we know how to write down the equations of v1 and v2. So in order to remember it, I'm writing the equations. V1 v2 is equal to 1 sorry z11 z12 z21 as well as z22 multiplied with I1 as well as I2. So now from this matrix, the value of V1 is equal to Z11 I1 plus Z12 I2. It's one equation. And the next equation is V2 is equal to Z21 I1 plus Z22 I2. So in this equation, what I'm going to do here is, I'm going to perform the output as open circuited. Okay, so when output is open circuited, I2 becomes 0. The ultimate terms are Z11 is equal to V1 by I1 is an impedance, and Z21 is equal to V2 by I1. So now let's try to find out Z11. Okay, what is Z11 in this equation? So in this equation, we need to make I2 equal to 0. So when you are making I2 as 0, then you can see here there's no current. Automatically the network is solved in this fashion. So you have an R3 resistor R1 as well as continued with R3 and continued with R2, R1, R3 and R2. So now what happened here is, this is open circuited. So whenever it is open circuited, what is the voltage at this point? V2. What is the voltage at this point? 0. 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 What is the voltage at this point is V1. So now since it is open circuited, the current is 0 and voltage is maximum, and automatically this will be moved to this point. This will act as an V2 now. That's how the network is solved. So now we need to find out V1 by I1. So when you see here, the current is entering this branch and it comes to this junction point, it gets divided. And the current which flows in R3, the same current flows across R2 as well as R3. I can say these two are connected in series and these two are connected in parallel with R2. So now the resultant network resembles like this. Okay, so you are having an V1 and you are having one resistor which is nothing but this is R1, and applied voltage is V1, and already told the current which flows in R3, the same current flows across R2 and across these two branches. So this is the node points. Okay, across these two nodes, if you want, you can label as node 1 and 0th node. Node 1 as well as 0th node, uh, R1 is connected as well as R2 and R3 are connected in series. So R2 plus R3 are connected in series. Now again, when you see this network, the current flows from this point and the current divides across R1 and R2 and R3. I can say these two branches are once again connected in parallel. So when they are connected in parallel, how to write down is, I can draw the same V1 and across 1 and 0. So these two are connected in parallel. When two resistors are connected in parallel, what is the formula is? product of resistors R2 R1 into R2 plus R3 divided by sum of resistance R1 plus R2 plus R3. So what is the current flowing? I1. Now we want a relation for the first one, V1 and I1. So how to draw this relation? We can see here. So the relation we are going to establish now. We want a relationship between V1 and I1. So this V1 and I1. So the voltage at this point, the voltage at this point is V1. The voltage at this point is 0 volts, and I1 is the current flowing. So from here I can write down I1 is equal to, how to write down the current I1? The current which flows across this resultant resistance. So I1 is equal to high voltage minus low voltage by resistance. So what is the high voltage? V1 minus 0 divided by R. What is R value? Which is R1 into R2 plus R3 divided by R1 plus R2 plus R3. So the resultant, we require the ratio of V1 by I1. So move this term to the numerator. That is V1 by I1 is equal to, so R1 into R2 plus R3 divided by R1 plus R2 plus R3. So this is the first what is asked in the question, V1 by I1. Okay, so that's how we are solving the V1 by I1. So similarly, we need to find out. So now we successfully find out Z11, which is V1 by I1. Okay. So now let's try to find out next term. The next term, let's try to find out V2 by I1. Okay. So how to find out V2 by I1? So half of the part is completed. So now we need to find out V2 by I1, the same circuit. This is open circuited. Okay. I'm drawing the same circuit. So how to find out that one is, draw the network as output port is open circuited. Okay. So this is R1, this is R3, this is R2. The voltage at this node is V1, voltage at this node is 0 volts, R1, R3, R2. Now here we have the V2. We require relationship between V2. So automatically what is the voltage? Since it is open circuited, this is plus V2 and this is 0 volts. So now what is the current is I1. So now in order to understand it, let's try to mark the currents whatever you want. So we require a relationship between I1 as well as V2. So that's why I am assuming a current which is a new current which is some I3 current. Okay, so now how to write down the current I3? Okay, so current I3 is equal to, okay, so the current I3 flows only across R2. Okay, so I3 is equal to high voltage. What is the voltage? What is the polarity of leaving? Plus V2. And what is the voltage at leaving? 0 volts. High voltage minus low voltage divided by resistors. If you want to analyze the nodal analysis, you can see my previous video where you can understand completely about nodal analysis. Now it is V2 by R2, but already I am having V2, but I need to transform this I3. Already we have V2, but I require I3 in terms of I1. Okay, now let's try to check this relation. Now how to write down this I3? So I3 is the current in this branch. How to write down the current in this branch? So current in any branch you can find out with the help of current division rule. Okay, so with the help of current division rule, I'm going to solve this problem. So current division rule says here is, so as per the current division rule, what we are going to have here is, so the current in this branch. What is the current in this branch? So current in this branch is nothing but total current. What is the total current? I1 multiplied with. So I want the current in this branch. What is the branch in parallel to this branch? Actually, uh, these R2 and R3, the same current will be flowing, which is nothing but I3 only. So this is one branch and this is one more parallel branch. I can say these two red color branches are connected in parallel. So whenever two resistors are connected in parallel, we can find the current by using current division rule. So I want the current in this branch, which is nothing but I3. This current is given by the formula total current. What is the total current of the network? I1 multiplied with the branch resistance, the branch current, which is opposite to this one. Okay. So what is the resistance? What is the branch which is opposite to this current, which is nothing but R1. So this is nothing but R1 divided by the sum of resistors which are connected in parallel. What is the first parallel resistance? R1 plus. So here this also one parallel branch, but these two are connected in series. So I'm going to write down R2 plus R3. If you want to understand more, please try to watch my previous lecture videos on current division rule. Okay. So total current into the opposite branch resistance divided by the sum of resistance which are connected in parallel. This is one resistor connected in parallel, and next resistor which is connected in parallel is R2 and R3. That is equal to I3 I express successfully. You can see here I3 expressed in the form of I1. So I1 I got, but here I am going to have V2 by R2, but I need the relation of V2 by I1. So how to write down the relation V2 by I1? So this is V2 here, this is I1 here. Therefore V2, this term will come to the denominator as I1, and the term which is there in denominator will go to the numerator, which is nothing but R1 R2 divided by R1 plus R2 plus R3. So this is the value of Z21. So this is the value of Z21. We successfully we have been calculated, which is R1 into R2, R2 plus R2 plus R3. Okay. So by this lecture, it's very clear. So we successfully find the value of Z11 as well as Z21. So now this is how half of the part is completed. Now coming to the second part. Okay. So in the second part, how we are going to solve is the same network we are taking. Okay. So we have this network. So in this network, what we are going to do is, previously we had made I2 as 0. Okay. So now in this equation, now we are making I1 as 0. Okay. So when you make I1 as 0, automatically you will be getting the remaining two parameters. Those parameters are Z22 is equal to, what is Z22? V2 divided by I2 is one parameter. Next one, Z12 is equal to V1 divided by I2 is the next parameter. Okay. So successfully we need to find out two. So already we have been find out in the previous, we had been find out Z11 as well as we had find out Z21. So now we are going to find out Z12 as well as Z22 in this session. Okay, let's try to verify now. Okay, so here what is open circuited? Input port is open circuited. Input port is open circuited. So this port is open circuited. The current becomes 0 here. So I'm going to redraw the network. So this is V1 and this is open circuited. The resultant branches you are going to have as R1, R3, R2 with a voltage of V2 and a current of I2. So here I1 current is 0. Whenever the current is 0, the voltage will be maximum. Therefore, what is the voltage at this point, which is V1? Automatically the voltage here is V1. The voltage at this point is 0 volts, at this point is 0 volts, at this point is 0, and this is 0. Okay. So these two are in parallel. Automatically here the voltage will be appearing. So now, whenever you make it open circuited, automatically the voltage is maximum at this point. Automatically, the voltage will be available at this point as some V1. Okay, and now let's try to find out with output driving point impedances. Okay, so now I require a relation between this V2 as well as I2. Now what I'm going to do is, so here you can see here the current I2 is entering, the current come to this node and gets divided across R2, and the same current flows across R3, and there is no path for it, automatically it has to flow across R2. So I can say that this R2 branch and R2 and R3 are connected in parallel. So these two branches are connected in parallel. Whenever these two are connected in parallel, so how to find out is very simple. Okay, so here we are going to redraw the network. The voltage is V2, and here you are going to have a current of R2, and this is a one more parallel branch. So what is this value? R3 and R1 are connected in series. We are going to write down it as R1 plus R3. So, and voltage at this point is V1, and here it is 0 volts, 0 volts, and 0 volts. The voltage at this point is V2. Now I require a relation between V2 and I2. You can see here these two branches are in parallel. Whenever these two branches in parallel, let's try to mark this as some node 1. Okay, between node 1 and between node 1 and 0, these two branches are connected in parallel. That resistor I am drawing here. Okay, so what is this resistor? This is nothing but product. I mean, whenever two resistors are in parallel, the formula is product of resistance R2 into R1 plus R3, the product of resistance divided by sum of resistance. What are those sum of resistance? R2 plus R1 plus R3. Okay, and now we are going to get this voltage as V2 here. So this is the voltage V2 and this is the current I2. Now I require relationship between V2 and I2. So the current I2 I can write down as current I2 is equal to, what is the voltage at this point? This is plus V2 and this is 0 volts. The current which is flowing in this branch is high potential minus low potential. So this current is flowing, this I2 current is flowing, what are the direction I am showing? The current I2 is flowing in this branch. Okay, so I2 I can write down as high potential minus low potential divided by resistance, which is nothing but R2 into R1 plus R3 divided by R2 plus R1 plus R3. But we require the ratio of what ratio we require? We require the ratio of V2 by I2. Okay, so now the ratio of, so this I2 will come to denominator. We can write down the ratio of V2 divided by I2. Okay, the ratio of V2 divided by I2 is equal to, so this term will come to the numerator, which is R2 into R1 plus R3 divided by R2 plus R1 plus R3. So this is V2 by I2. Successfully we find out the one parameter. Okay, so we are successful now in finding out this parameter. Now we need to find out this parameter. So how to find this parameter? Okay, So how to find this parameter is V2 by I2. Okay. So here in this network, the same network we are going to get it as like this. So R3 followed with R1 followed with R2 and with a voltage of V2 and a current of I2, and this branch is R2, this branch is R3, this branch is R1. Now when you come here, how we are going to solve it is, here this voltage at this point is V1. We require a relationship between V1 as well as V1 as well as I2. These two relations we require. How to draw the relation is, let us try to assume the current in this branch is some I4. How to write down the current I4? Here. Okay. So the current is flowing here as some I4. Okay, but the original current in, oh, this is a series branch. Okay, therefore the original current flowing here is I4, but I am writing this I4 with respect to V1. So the current I4 which is flowing in this branch, only this branch. Okay, so this branch I am writing which is I4. So with respect to V1 I am writing. So I4 I can write down it as high potential is V1 minus 0 divided by R. What is the value of this? R1. So if you are writing with respect to V2, no, this is entirely different again. I4 is equal to V2 minus V1. That's why I'm not writing like this. Okay. So I want only V1 relation. So I got, so now I1 I got and I4 I require. Okay. So this I4 I don't want. Why? Because I require the relationship for I2. Okay. Now I want to express this I4 in terms of I2. Okay. I4 in terms of I2. So how I can write down is, so here in order to obtain this relation, I'm going to apply current division rule. So those are new to this class, you can go and see my previous video how to apply current division rule for an parallel branch. This is one parallel branch, this is another parallel branch. Okay, so I can say these two branches are parallel branches. Across a parallel two parallel branches I can apply a current division rule. So how to apply the current division rule? So now let us apply it. So I4, I want the current in this branch. Okay. So I4 current is nothing but total current. What is the total branch current? Total current is of the network is I2 into. So I want the current in this branch. What is the branch? This is the branch. I require the current I4. What is the branch which is in parallel to this I4 is R2. What is that value? R2 divided by the sum of branches which are connected in parallel. So what is the branch first which is connected in parallel? So this first branch is R2 is one branch, and another branch which is connected in parallel is this branch, the sum of resistors, which is nothing but R1 plus R3, that is equal to V1 by R1. But we require the relationship between V1 and I2. We got it. V1 by I2. Okay. So therefore V1 by I2 is equal to this R1 will come to the numerator, which is R1 R2 divided by R1 plus R2 plus R3. So successfully we find the impedance Z12, which is nothing but inverse transfer impedance. Okay. So that's how we are successful in finding out all the parameters of the network. So you can see all the parameters clearly here. So we find out Z12, Z22, and we have been find out Z21 and Z12. So this is not directly by listening class you can understand the things better. You have to practice. So until you practice, the things will not be very clear. If you want to get it out, I will clarify here. I'm revising the concept again. So you have the V1 equation as V2 equation. And now take this network. And initially what we are making is output port, we are going to make it as open circuited. When you make it open circuited, the V2 will be shifted to this point, and we are going to find out the first term V1 by I1. So V1 by I1 means these are two parallel branches and these are in parallel, automatically the product of rest. We have find out the ratio. So when you come to this, the procedure is same. Okay. So here we got V2, but I require a relationship between V2 and I1. For that, what I'm going to do is I am nominating a current I3, and I'm writing that current as V2 minus 0 by R2. Now I'm expressing this I3 in terms of I1 by using an current division rule. By using this current division rule, I'm expressing in the required format. So what is the formula of current division rule is total current into a resistive branch which is connected in parallel divided by the sum of resistances which are connected in parallel. This is what I applied. Okay, so this is the current I require. What is the branch in parallel to this? R1 divided by the sum of resistors. These two branches are connected in parallel, R1 plus R3 plus R2. So same procedure I employed in the, rather than doing with output port, I have been done with input port. So I had done with input port, then you can get the same equations. So successfully we have been determined the Z parameters of the given pi type attenuator circuit successfully. So this is all about finding out the parameter. So if you're watching for the first time, if you feel the content is very useful, please give one like and please share with your friends. And if you have any comments, let me know in the comment section. And if you are watching for the first time, please subscribe my channel, which is a free channel for the development of students. So I can say directly one thing: if you watch my video, you'll get a clarity on how to solve, which is not there in textbooks. Okay, and after listening my lecture, you write down the given question as it is and try to solve of your own and verify you are getting the same answer or not. Then where it will improve your brain. Okay, so hope we'll meet in the next problem. Thank you for watching.